Okay. During a race, Bernie ran 9 meters every 4 seconds, while Wendell ran 2 meters every second and got a 9-meter head start. If the race was 70 meters long, did Bernie catch up with Wendell? If so, when? So, I'm going to go back and kind of sketch this a little bit. So here's my starting line. I've got Bernie. It has to start at the starting line, but for some reason we've decided that Wendell should get a 9-meter head start. 9 meters. So here's where Wendell starts. And I've got their respective rates, right? Bernie is traveling at 4 meters every, oh no, 9 meters every 4 seconds. 9 meters per 4 seconds. And Wendell ran 2 meters every second and got the head start. And then the thing that we're concerned about is Bernie going to overtake Wendell within the 70-mile long race? So let me start by writing an equation that models each of these. So I could say that I'll do y. This is y is Bernie's distance from the start. So y is how far each runner is from the start. So I'm going to say for Bernie, his distance from the start is equal to 9 meters every 4 seconds, right? So every single time x increases by 9 fourths. Yeah, that would be, yeah. 9 meters every 4 seconds times how many seconds would give me meters. Meters per second times seconds totally gives me meters. Plus no head start. I could put plus 0 if I want, but I don't need to do that, so I'll just leave that. And then I'm going to do Wendell's equation, right? Wendell's distance from the start is going to be 2 meters every second plus, Wendell got this 9-meter head start. So I think I want to figure out, I guess I want to figure out when they intersect. So if I'm thinking about this kind of conceptually, I got a graph in 2 space like this, and up here I could have, here's 70 meters, right? That's that distance where the race finishes. And I've got Bernie starting here. Let's see, 9 over 4 is a faster speed, right? 9 divided by 4 is like 2.25, so it's 2.25 meters every second. So Bernie does have a faster rate, and Wendell has a head start and has a slower rate. But the thing I don't know, and I don't want to draw it so it looks like it's true, is I don't know where the 70 meters is going to be. I don't know if they're going to meet before the 70 meters or after. So what I'm going to do is I'm just going to ask the question, well, where do they meet? And if they meet at a spot that's less than 70 meters, if they meet before 70 meters, then Wendell won. No. If they meet before 70 meters, then Bernie won. If they meet after the 70 meters, then Wendell would have won. So my question is, well, let's just solve this as a system of equations, right? And this will tell me the x and y where they actually meet each other, and then we can think about where that is in terms of the number 70. So to do this, this is totally set up for the equal values method, right? I have y is this and y is this. I'm just going to say, oh look, well y is equal to itself, right? In the context of this situation, I want to know when the y's are the same. One of my y is 9 fourths x, and the other y is 2x plus 9. I'm going to multiply both sides by 4 to get rid of the fraction. The left-hand side is going to become 9x. The right-hand side is going to become 8x. And 4 times 9 is 36. If I take away 8 from both sides, I get that, take away 8x from both sides, take this away from both sides, I get that x is 36. So 36, remember, is my time. So at 36 seconds, they will meet. The question is, where are they at 36 seconds? Well, if I put that into Wendell's equation, 2 times 36 plus 9 gives me that they're at 81 meters when they meet. Okay, so that changes things. I can go back and look at this now conceptually, and I can say, well, this is Bernie's equation, right? Uh, this is Wendell's, who has a slower rate but has a head start, right? So here's where time is 0. At time 0, Bernie's at spot 0. At time 0, Wendell's at spot 9. This is the head start that Wendell got. And you can see, because the slope of this is slower, you can see I'm saying that clearly this is a slower rate. So maybe I'm exaggerating it. But what I know now is I know that they meet when x is 36 seconds, and the location where they would meet if they kept running is 81 meters. Well, this race ends at 70 meters. So the scale is terrible on this, but the big idea conceptually is that, well, if the race is ending at 70 meters, who's the first person to end the race? Well, the first person to end the race is Wendell, right? And then some amount of time later, then Bernie would cross the finish line. So the answer here is that Bernie does not win, right? Bernie does not win. And I'll just write Bernie, Bernie, does not win. Bernie, let's see, reaches Wendell at 81 meters if they kept running. Wah, wah, wah. But the race is over at 70 meters. So again, this was taking one representation, taking this verbal representation. I came up with a system of equations, and I was able to figure out when they meet at 36 seconds, which is 81 meters from the start, but the race finished at 70 meters. So Bernie does not win, Wendell wins.